For question 1, we need to find the equation that represents this line. And this is a two-step process. I want to find a y equals mx plus b, where m is the slope and b is the y-intercept. And here I have this formula for slope. So I'm going to start by solving for m. So let's do that. In question 1, I see I have a point -3, -5, so I'm going to write that down. And I have this other point, looks like 1, 3. I'm going to call this one x1, y1, and this x2, y2. And therefore my slope is equal to y2 minus y1, that's 3 minus a -5, over x2 minus x1, that's 1 minus a -3. And I just want to carefully simplify this. This is 3 plus 5 over 1 plus 3. That is, my slope is 8 over 4, or simply 2 over 1. I'll just write that as 2. So in terms of my equation, I'm halfway there. I know it has to be y is equal to 2x, and it's got to be plus whatever the y-intercept is equal to. But if you look at your graph, I can actually see that it's right here. The y-intercept is the point 0, 1, and b is the y value of the y-intercept. So I'm going to put a 1 here, and this represents the equation of the first line. Let's try that for the second problem. Again, I have 2 points. Looks like -6, +7, as well as 3, 4. The order doesn't matter, but I'll call this x1, y1, and x2, y2. Therefore, my slope is going to be y2 minus y1, 4 minus 7, all over x2 minus x1, which is 3 minus a -6. The numerator is -3 over, and the denominator is 6 plus 3, that's 9. My slope is -1 over 3 when I simplify it. Okay, so my equation must be y is equal to -1/3 x, and I just need to know, well, what's the y-intercept? Well, that's right here. That's the point 0, 5. So the y value is 5. And this is the final answer. The 2 points for problem 3 are, let's see, I have -7, -5, and also -1, -5. This is my x1, y1, and this is my x2, y2. Therefore, my slope is y2, that's -5, minus y1, which is minus also -5. x2 minus x1 is -1 minus a -7. So this is really -5 plus 5 over -1 plus 7. Continuing, -5 plus 5 is 0, and the denominator is -1 plus 7, which is 6. And 0 over 6 is the same thing as just 0, which that's my slope. So here's my line. Y is equal to 0 times x plus the y value of the y-intercept, which is also here, at b is equal to 5. So 0 times x, the slope of 0 means that the line isn't going up or down, but actually it is a horizontal line. You don't even need to write this portion since 0 times anything itself is 0. I think the most concise way to write this is y is equal to 5. And that is the equation of my line. All right, for the next one, my 2 points are 2, 2, and that's 4, 8. I'll label it x1, y1, and x2, y2. And my slope is going to be y2 minus y1, that's 8 minus 2, over x2 minus x1, which is 4 minus 2. This is 6 over 2 or simply 3 over 1, I'll write that my slope is 3. So my equation must be of the form y is equal to 3x, okay, again, plus some y-intercept, and my y-intercept is here at -4. So you could put plus -4. It's just customary to write that as 3x minus 4. And that is the answer to this one. All right, let's try to figure out the slope for the following line. The 2 points we have are 4, -3, and let's see, 4, 7. I'll call this x1, y1, and this x2, y2. So let's see, y2 minus y1 is 7 minus -3, and x2 minus x1 is 4 minus 4. That's really 7 plus 3 over 4 minus 4, that's 0. That means my slope is 10 over 0. And that's not 0. In fact, I typed this into my calculator and it said error. So what does this mean? It means that it is impossible to express this as a line y equals mx plus b. This is not possible. But this thing is still a line. So how would I write a line that is vertical? Well, the slope technically we would say is undefined, so I'll write that. It just means that there's no number associated with 10 divided by 0. It can't be done. But anytime this happens, the line is of the form x is equal to a number. And since all the x's are equal to 4, that line is x equals 4. That's a vertical line. Now for the last problem, here I have y equals 2x minus 2, which is definitely the equation of this line. The y-intercept is -2, and the slope is 2. You go over 1, up 2, over 1, up 2, and so on. So we're pretty good with solving equals. It just means graph this line. But what if it wasn't equals, but it was greater than or equal to? What does it mean to graph this thing, or solve this? So the answer is, it's not just the line itself. This line is dividing the plane into 2 pieces. When you say greater than or less than, you're asking, well, which side of the line do I want to include? The answer is going to be everything over here or everything over here. I think the simplest way to figure out which side to choose is to pick a point on either side. I'm going to choose the point 0, 0. I'm going to call this a test point. It's up to you to choose this, and there's a lot of options. I'm going to put this point into this inequality. If this point makes this true, it means that every point on this side makes it true. Now, if this is false, it means that all these points are false, and the other side is the side that we'd like to choose. So I'm going to put this 0 in place of x, this 0 in place of y, and see what happens. So we have y is greater than or equal to 2x minus 2. I put 0 in for y, and also for x, and simplify it. Is this true? Is 0 greater than or equal to -2? And yes. What this means for us is not only does this point work, every point on this side makes the inequality true. Just, to check it out, like what if we picked a point on the other side? That's the point 5, 0. It should make this inequality false. I'm going to put 5 in place of x, 0 in place of y, and see what happens. So that's 0 for y, 5 for x. I simplify it, and I'm asking, is this true? Well, this is 10 minus 2, and this says 0 is greater than or equal to 8, and that is false. So was this true? The answer is no. It didn't work for this point. It won't work for any point over here. And this is the answer to the problem. It's the line itself, but every point on this side.